There are creatures on this planet that have evolved incredible powers of survival. These animals use a bewildering array of ingenious tactics to outsmart some of the world's most deadly predators. Their seemingly magical skills make scientists wonder whether such tricks could ever be harnessed by humans. Take the octopus. This animal is the master of disguise. It has evolved a unique way to foil attacks by predators. It can change the color of its skin.
Camouflage allows the octopus to escape by blending in with its natural habitat.
The octopus uses the power of invisibility to survive and thrive in the dangerous realm of the oceans, a deceptively simple vanishing act, but a phenomenally complex feat to achieve. To reveal its mysteries, we'll venture to the coral reefs of Hawaii.
Heather Yitalo Ward is on a mission to uncover the secrets of the octopus.
It is fascinating behavior that they can do this instantaneous change. And it's not just the color of their skin, it's also the texture of their skin, their posturing. All of these things help contribute to the way that they can camouflage in the wild.
She wants to capture the process of camouflage on camera.
If you have video of these octopuses that are camouflaging, then you can see precisely how quickly this is changing.
Underwater cameraman Mike Prickett and local fisherman Bert Taniguchi join her to help track down a species known as the day octopus.
He's been fishing his whole life. His family has been fishing for generations. He's really got the eye. He's got that trained eye.
Most octopuses are nocturnal, but the day octopus is unique. It feeds in daylight. In the clear Hawaiian water, however, it too is exposed to predators such as sharks and rays. Out of necessity, it's become the undisputed king of camouflage.
They're not like trained animals who sell out in the wild, so he's got to kind of try to sneak up on him.
Heather and Bert scour the sea looking for any signs of life. If an octopus spots them first, it could camouflage before they even see it. Suddenly, Bert's expert eye catches something moving. It's the day octopus. The black cloud disorientates Mike. The octopus's ink not only acts as a smokescreen, its pungent smell dulls the sense of its predators, throwing sharks off their trail. Heather and Bert must start looking again. Bert spots something below him. This time, Mike keeps a safe distance. With Mike in hot pursuit, the octopus is constantly looking to find an escape. In the shadowy water, it spots a gap and changes its skin to match the coral.
We found one, and we got some great footage.
If I was a predator, I was totally confused. I didn't know where that thing was, so if it would have survived me if I was hunting it. It was amazing. It was a lucky day. You got octopus lady and octopus eye together. The perfect team. You see that, Brooke? Come sit right next to this.
It's very clear, and you can really see the octopus well, and you can see those changes. It's stunning. It's really beautiful footage, and I'm so happy to have Mike out here because I haven't been able to do this before.
The secret to the octopus's extraordinary superpower lies in its skin. To understand how it can change color within the blink of an eye, we must take a closer look at its body.
The skin is made up of organs called chromatophores. These contain sacs filled with one of three pigments: yellow, brown, or black.
Each sac is surrounded by muscles. By contracting these, the octopus can adjust the size of different sacs and change its overall color.
We've got some footage now of an octopus in the field camouflaging, but really in order to do the research on this species, we're really going to have to look at it on a closer scale. Now what we want to do is go back, see if we can catch an octopus and bring it back into the lab, and so we can look really closely at those chromatophore cells.
And the best way to catch them alive? The Hawaiian three-pronged spear.
It's an ancient tradition, goes back to the old Kikamehameha days. When the first Hawaiians came to the islands, they didn't quite have the fiberglass and graphites that we got now. They have just a stick. I'll tap him real softly right on his head, and then he'll climb up their spear. And as soon as he climbs up the spear, I'll grab his legs and the spear, and I'll slowly pull him out.
To stand a chance of catching one, Heather and Bert must look for an octopus in its den. Octopus make their homes from the rubble of the reef, hiding under chunks of coral. They feed on crabs and shrimp, leaving the shells outside their entrance, the telltale sign that someone's home. They spy an arm. Bert moves in. The octopus is using all its defensive tactics, inking and twisting its body. Bert grabs its beak so the animal doesn't bite him. Finally, it's in the bag.
We got one. All right, let's see if there's a male or female. Oh, this is a male. And the way you can tell that, we've got the third arm here. It's called the hectocotylus. You can see it's a bit thicker and shorter than the other arms around it. That's the specialized arm that he uses to distribute his spermatophores into the female. So let's get this guy back to the lab.
Back at her lab on Coconut Island, Heather puts the octopus's camouflage skills through a series of controlled experiments.
This camera is allowing us to see the chromatophores at a really small scale. Oh, yeah, perfect. You can see the dark cluster of brown, and then you can see some yellow around it. And these are the chromatophores. We can see how these large-scale pattern changes are occurring on these tiny little cells. And he's really going to town on them. You can see him expanding and contracting right under our eyes. Even on this tiny little patch of skin here, you can see hundreds of chromatophores. Let's see if we can get that focus here a little bit. Let's see here.
This octopus has 234 chromatophores per square millimeter.
Every species of octopus has a different number of chromatophores. When you go into the deep sea, they're not really needing to camouflage as much as they are in the reef. These are the day octopus, and so since they're out during the day, they've just got this incredible network of chromatophores. Millions of chromatophores throughout the body of the octopus are controlled individually by the brain. It sees its surrounding, and then it changes instantly. They're masters of disguise.
This amazing footage, shot near the Grand Cayman Islands, shows how the incredible octopus can fool even us.
It seems like an impossible feat. If we look at the footage again, slow it down, and play it in reverse,
We see it takes less than 1 second for the octopus to manipulate its skin with perfect precision.
this range of color requires something more than just the 3 pigments in its chromatophores. To allow the octopus to blend in with the bright and dazzling colors of the reef, it can contract its pigment sacs to reveal a layer of reflecting cells underneath. Filled with a colorless protein, these behave like microscopic mirrors. They reflect light falling on the octopus's skin, scattering them in every direction.
This cuttlefish is a close relative of the octopus and shares the amazing technicolor dream coats of the deep. The skin of an octopus, however, has one more trick within its outer layer that plays a vital role in ensuring invisibility in 3D. Heather adds chunks of coral to attack.
What we're doing here is we're trying to look at an octopus having his skin change textures.
She wants to measure to what extent this octopus can modify its skin.
He's getting a little bit of a lighter color, so he's starting to settle in with the coral there. It's really incredible, actually. And as he's breathing in and out, you can see the protrusions coming up out of the top of his head. And there they come. What the octopus is doing is it's raising the muscles of its skin so that it can raise these papillae. That's what we call the little horns that are on the back of the octopus. They've got a couple above their eyes and a couple on the back of their mantle, and they can raise their skin around their arms, too.
This octopus lifts its papillae 1/2 centimeter off its skin. But this is a juvenile. Adults can raise theirs up to 2 centimeters.
Just in the same way that it can contract or expand the muscles around the chromatophores, it can contract or expand the muscles on the top layer of its skin where the papillae are in order to manipulate that texture. It's another way that they can confuse their predators into thinking that maybe that's just a piece of coral over there.
Coral provides the perfect backdrop for camouflage. Rich colors and a tapestry of textures allows the octopus to show off the full gamut of disguises. The most dangerous place for an octopus is open water. Camouflage is a useless defense if there's nowhere to hide. Instead, some species use their powers of disguise to go on the attack and scare off predators. But the so-called mimic octopus does more than merely change color and shape. It alters its behavior to impersonate other sea creatures. Here, it pulls its arms in close and hugs the seabed so it looks just like a flounder. The mimic octopus was only discovered a decade ago. Perhaps we've been seeing it for centuries, but mistaken it for other creatures of the deep.
The octopus's coat of many colors allows it to thrive in seas full of hungry predators. Few other creatures are lucky enough to possess this remarkable ability, but those that don't have evolved different strategies of survival equally impressive. Meet the electric eel. This animal possesses a deadly weapon to fend off predators. When attacked, it fires a thunderbolt of electricity, stunning its prey.
Electric eels live in tropical streams. They feed on small fish, but are themselves preyed upon by natural-born killers such as crocodiles.
This remarkable footage, however, suggests the strike of an electric eel is powerful enough to send crocodiles into cardiac arrest.
As the 2.5-meter-long caiman crocodile attacks, it appears to freeze, stunned by the current sent through its body.
To find out the truth and how it's possible for an animal to unleash an electric shock, we will travel deep into the South American jungle.
We're in Suriname, flying over one of the most remote and pristine areas of rainforest on the planet. This is a really exceptional place. It's so remote, though, that we've had to charter our own aircraft to fly in. The only way in here is by Cessna.
This is Will Crampton's fourth and final flight on a journey deep into the depths of the Amazon, the only place on Earth where electric eels live.
This is it, we're coming into land, field trip on the Copenhagen River. This is one of the best places on the planet to catch electric eels.
His goal is to measure just how powerful their deadly strikes are.
So we've just arrived, the pilots cut the engines. This is a really remote place. We're in the middle of nowhere, there's no going back, and the electric eels are waiting for us out there. I love it. We're quite lucky because the skies have just closed in. We've landed just in time, actually. Everything's packed carefully, but you never know, I'm human, I fail sometimes. If I've forgotten something, then essentially it's game over. There's no way we can get resupplied here. The plane is going to leave soon, and it won't come back until it comes to get us in 5 days' time.
Will has come to the Raleigh Falls Nature Reserve. Here, the Copenhagen River is home to the electric eel. Fish are among the only creatures on Earth that use electricity to hunt and defend themselves. The reason is simple. Water conducts electricity, making it the perfect weapon.
It's been raining for the last 2 or 3 days, and water levels come up at least 2 or 3 meters from last week. So what that means is that the volume of water has really expanded, and instead of being concentrated in the main river channel, the eels are now able to swim out into the floodplain, and that makes our job much, much harder.
This is what Will is looking for. He has just 5 days to find an electric eel. Catching one won't be easy. The floods have sent the electric eels scurrying up the banks of the Copenhagen in search of their favorite habitat, stagnant pools and muddy bottoms.
We may have to actually walk up rainforest streams until we get to the flood maximum, and then look for electric eels in the streams above that. So this is going to mean a lot of walking, a lot of hard effort.
This is a dangerous mission. Finding electric eels isn't like normal fishing. No one fishes for them. Locals are terrified. Stories abound of people disappearing in these waters.
This looks like a very promising location here. It's a beautiful waterfall, and this is going to be very, very well oxygenated, and that attracts fishes. And where fishes live, electric eels come to hunt. So this is the most important device that we're going to be using. This is an electric fish finder. It's a waterproof box that we built in the lab. It's connected to a cable, and we have 2 pairs of electrodes on the end here, exposed wires that are going to pick up the electrostatic fields of electric eels in the water. Inside is an amplifier, which will amplify the signal and plays it through a loudspeaker. So I'm going to be able to hear the discharges of these fishes. Clearly, there are some dangers that can generate pretty high voltages. Luckily, this device not only enables me to find electric eels, but step away if one got very close to me. Switch this on, and start waving it around, see if we can pick anything up. I'm listening out for the electric discharges of the eel. They have a very characteristic sound. It sounds like popcorn popping in a pan. At a regular frequency.
Every gully within a kilometre of the Kopanami is full of water. Will must scour them all until he hears the electric eel's distinctive discharge.
There doesn't seem to be anything around here. But I haven't heard anything. There's just nothing around here, nothing. So I think the best thing to do is probably move further up this creek and see if we can find anything down. This place looks good. Let's try there. But right now I'm not hearing anything. There doesn't seem to be anything around here. It's very deep, so I can't go any further. I think the best thing to do is try in another location a little bit further up this stream.
Will ventures deeper into the jungle. And as dusk approaches on day 4, his amplifier remains silent.
So we seem to be at the edge of the floodplain right now, and there's a really promising location right here. There's a sort of deep water area and a shallow inlet. Very often electric eels will come out of deeper water at night in search of prey. They'll patrol around the edge of these creeks and rivers.
This creek is his best chance.
I think I'm hearing something here. Oh, yes. Getting stronger. Getting stronger around here. Oh, yes. There's definitely one underneath this rock. I can hear him really clearly here. This is a great location. The problem is that they're hiding under these boulders. We're not going to be able to catch them now, so what we should do is set a trap. At night, they're going to come out of these holes. They're going to move into shallower water looking for prey. So in the morning, if we come back, we should be able to get one. This is a great location. Should we put the mouth of the trap here? Maybe coming down like this. This is the electric eel's nightmare, the fyke trap, the fyke net. We've set it in shallow water along the edge of the stream. And these 3 walls are going to guide fishes, including electric eels, into the mouth. Once it gets in, it goes through a series of hoops, and it goes through a bottleneck here into the cod end. Once it's in the cod end, it can't get back out. We have the cod end hanging out of the water. There's a very important reason for that. Electric eels are air breathers. They're obligate air breathers, which means they actually have to breathe air. If they don't, they'll drown. So we need to leave a space for them to come up to the surface and breathe.
The next morning, Will returns to the trap.
Oh, I can hear something. Oh, yes. Can you hear that? Yeah. We got one. Oh, there he is. Must have come in last night. It's in the trap. Probably about 60 or 70 centimetres long. Not a big one, but nice size. Everything went as planned. Fantastic. So I think what we need to do is get the net out onto the bank and then put the eel in there in that bag that we find in there. So let's move this around. That's an electric eel.
Will leaves nothing to chance. He examines the eel on land.
All right, so gloves on. Good, here he comes. And here he is in the cod end. Oh, look at that. Electrophorus electricus, the South American electric eel, magnificent animal. So he's not struggling too much. About 80% of his body volume is dedicated to electric organs, so they have reduced musculature compared to other fishes, so they don't tend to squirm around as much as a true eel would. I suppose some people might think these are rather ugly, slimy creatures, but for me they're absolutely beautiful, really magnificent animals.
The key to the electric eel's powerful shock is hidden beneath its skin. Looking inside the animal, you can see its unusual layout. All its vital organs, the brain, the heart, kidneys, sit right at the front of the creature. This leaves the rest free to house the eel's electric factory. This organ is made up of tiny discs of muscle, each generating a small voltage. In an adult electric eel, up to 6,000 of these discs are linked together like a stack of batteries. They add up to create one monstrous light bolt. A roll of fat coats the discs to insulate the creature and ensure it doesn't succumb to its own powerful sap.
Here we are in my field lab. We have some incredibly sophisticated equipment here, very expensive electronics. We also have a very cheap kiddie paddling pool here, which is just happens to be the best way of doing this in the field.
Will is now ready to measure the voltage of this electric eel. It's the first time anyone has attempted this in the field in over 70 years.
Electric eels generate incredibly high voltages, certainly higher than any other animal on the planet. We need to take them out and put them on this non-conductive surface, so the electricity is only flowing through these electrodes, positive electrode and a negative electrode. Handling electric eels is obviously not for beginners. This is a dangerous animal, so we're going to have to protect ourselves. I am going to put on a pair of rubber gloves rated for very high voltages to get it out of the tank. If I wasn't wearing the gloves, then this would be a very, very uncomfortable process. If he starts moving around, just keep him straight like that. Thank you. What we're going to do is we're going to place the electrodes on the head and tail of the fish. Okay, Sonny, could you hold this electrode and place it so there's a good contact on the very end of its tail, right at the end. That's good. So I'm going to place the positive electrode on its head. By provoking it with a tap on the head, I'm essentially simulating something dangerous, and it's going to react to that by generating this incredibly high voltage shock. Oh, yes. Wow. 492 volts. This is only about half a meter long. We've got 492 volts. A plug outlet in Britain would be 220 volts, in North America 110 volts.
The shock is the equivalent of putting your fingers into 2 live sockets simultaneously, enough to electrocute a human.
For an eel this size to generate 500 volts, outstanding. Imagine how much one of these really big ones generates.
Firing off a 500-volt bolt of electricity is an extraordinary feat for an animal. For it to strike with maximum power, each of the 6,000 discs along the length of its body must trigger their shock at the same time. But each of the discs sits at a different distance from the brain. To ensure the discs near the brain don't trigger before the ones at the tail, the eel has a specially adapted nervous system. It is wired so that signals traveling short distances move through thin nerves, slowing them down, whereas signals traveling to its tail take the fast lane down wide expressway nerves. This way, all discs discharge at the same time.
The key to the electric eel's deadly shock is not just the enormous voltage, it's the type of current it generates too.
The interesting thing about these discharges is that they only have a positive component to them. They're monophasic, and that means that they're direct current. There's no negative component which would make them an alternating current, or AC. Animals are more sensitive to DC. They're more likely to be paralyzed by a DC field.
So it seems as if the electric eels may have evolved a discharge that's not only high voltage, but has electrical properties that make it more effective at paralyzing things. This is an extremely effective defense system.
Is this what happened when the crocodile foolishly attacked an electric eel?
I've seen amateur films of caiman being paralyzed by electric eels. It seems very clear to me that those films are accurate, they're not faked in any way, that electric eels routinely use their high voltage discharges to protect themselves against big predators like caiman and anacondas.
This video shows the surge kill an adult caiman.
It's just this hitherto unknown world of electricity that we're just beginning to understand. Electric eels are simply unrivaled in the animal kingdom in this ability to generate high voltages. There's no other species on the planet that can generate 500 volts.
Armed with an electric weapon to fend off the mightiest predators of the Amazon, the electric eel is a born survivor. But perhaps the ultimate power of survival isn't just being able to hide or kill. Some animals possess the extraordinary ability to regenerate. Take the salamander. This small creature has the ability to regrow arms, legs, parts of its eyes, and even its brain.
The salamander lives in wetlands. It catches its prey by rapidly extending its sticky tongue, pulling the victim into its mouth. But its environment is rife with predators, such as snakes and birds. Sometimes it becomes the prey.
By regenerating crucial parts of its body, the salamander can cheat death again and again. Understanding how it achieves this incredible feat could one day enable humans to repair and regrow our own body parts. To discover more, we must head to California, where Professor David Gardner is unlocking the secrets of the salamander's superpower.
What you're looking at is the future in medicine, in biology. It's where we are all going, because these animals can regenerate, and they can regenerate all of their body parts.
David is investigating a species of salamander known as the axolotl.
This is the kind of animal you would find in the wild. They're from Mexico. It's got a lot of pigment. Some of these other animals that are white, those are pigment mutants. These are the healthiest axolotls you'll find anywhere in the world. These are animals that we are using and we justify using for experimental purposes because of the greater good and the promise of how we can really change the quality of life for humans. Some days I look at them and they're just, it's like they drive me crazy. But the reality is, of course, that they're quite remarkable animals. They have the secret to regeneration. It's not that they're cute. They have their little frilly gills and you just want to talk to them and say, just tell me, you know? How do you do this? How do you do this? We'll take this animal down to the lab and get the experiment started and see it regenerate over the next couple months.
Today, David starts an experiment to explore just how fast the axolotl regrows a lost limb.
All the evidence from molecular genetics would indicate that the genes that these animals have, the molecular mechanisms for regeneration, we share those. And so it's very, very compelling reason that we should be able to do this. The question is, how are we going to unlock that? What's the key? This is the key. This is the animal that can do it.
To unearth its secrets, David must get the axolotl to regenerate.
The way you start regeneration is to create an injury. So we're going to amputate the right arm on this animal.
With the animal fully anesthetized, David starts surgery.
So we're just going to begin to cut through the soft tissues. And then the bleeding stops very quickly. In the case of a human, in an amputation, you couldn't do it like this. You'd bleed to death. There's a lot of complications that don't happen in this animal. So it strikes us that these very early events that occur in this animal that are different from what happens with us, allows regeneration to happen.
Humans react very differently from salamanders when parts of our body are injured. Thick scars form quickly to stop our bodies from bleeding, but this inhibits regeneration. To see how the salamander reacts, we must magnify this model. The blood pressure of a salamander is very low, so when it loses a limb, skin cells can travel across the cut, sealing the wound within hours. There's no need for a thick scar. The thin layer of skin cells then sends a call to arms that guides nearby muscle cells to the area. These immediately begin rebuilding the lost limb.
To observe how the axolotl regenerates, David builds a rig in which he'll photograph the animal over the next 2 months.
We'll start with this first set of pictures, and we'll just build this whole series. And we got that one. I think you'll find it quite amazing. Seeing is believing. I mean, this is a classic example of that. If you didn't have animals like this, and I stood up and said, you know, I think we can regenerate, and people would think I'm crazy. Because they'd say, well, you know, what are you talking about? You know, you can't just like grow back an arm. But that's not the case. We have an animal that can do that. This really happens, and it's a real biological process. It's just what some animals can do very, very well. We don't do it very well, but we could be, you know, coaxed into doing it better.
These are the photographs of a regenerating limb. Within the space of just 8 weeks, the salamander regrows its lost arm.
The key to the salamander's miraculous recovery lies in its body cells, which travel back to the future. Following amputation, the cells revert back to an embryonic state. The biological program that ran when the salamander was a fetus, telling it to grow arms and legs, reboots. Neurons, muscle and blood vessels grow within the regenerated limb and re-establish the connections that were present prior to amputation. The salamander is not the only animal that has this unique ability. The gecko deliberately sacrifices parts of its body to fool predators. It's one of nature's most amazing getaways.
This gecko is a leopard gecko. It's a smaller one. They get a lot larger. And the species is typically found in southern Central Asia, typically in desert habitats. Leopard geckos, as compared to other lizards, are fairly slow-moving. They can afford to do this because of their very unique way of dealing with predators. When a predator actually grabs onto the tail, it can initiate the dropping of this tail, which is a self-amputation.
To understand how the gecko's tail pulls off this super stunt, Tim trains 2 high-speed cameras on its tail, capable of filming at 500 frames per second.
I'm just going to gently pinch the base of the tail here.
Tim simulates an attack. The gecko drops its tail.
You can see it just did a flip, and it's truly amazing. It's very unpredictable. It just swings back and forth.
The tail's movement is impossible to follow with the naked eye, but Tim's high-speed cameras allow him to see what's really going on.
Clearly, this provides a wonderful distraction for the predator. This is plenty of time for the lizard to get away.
The movement might look random to the naked eye, but in high speed, Tim discovers 2 very distinct movements.
But it's swinging back and forth, and then all of a sudden initiates a jump. Whoa, look at that. 1, 2, 3, 4. No figure skater could do that.
Rhythmic swings from side to side, and acrobatic flips up to 3 centimeters in height.
And this is truly amazing. You can imagine if a predator was trying to eat this tail, how much trouble it would have. In this case, the tail is actually acting like an animal and moving around quickly so that the lizard itself can survive.
Other animals have body parts that continue to move after being severed, but the gecko's tail is unique in that it has 2 very different movements.
It's truly, I think, phenomenal that this tail can actually do this when it's not attached to the body. And so for it to do that without a brain is absolutely remarkable. When colleagues and I first saw this tail movement on the video, we were absolutely astonished. You can see here the very typical swinging back and forth, but for the tail to flip and jump as fast as it did was truly phenomenal. You don't want to just sit there swinging back and forth, because even we could slowly just focus in on it and grab the tail. But if it's swinging back and forth and then does a jump and then 3 more jumps and a flip, you're not going to be able to predict where the tail is going to go or how it's going to move. And you can imagine if a predator is trying to get this tail for 30 seconds or a minute, it might give up. We were just jumping up and down with excitement when we first saw the video of what the tail could actually do. The ability to drop your tail and give it to a predator so that you can survive is truly one of the great, great evolutionary stories of the animals that are walking around today on the Earth. And not only that, but they can regenerate this tail and potentially do this one more time when they meet another predator in the future.
The gecko's tail stores excess fat for lean times when food is scarce. In a crisis, however, it can afford to lose its tail and survive until it grows back.
A lot of animals certainly have powers to attack things and hunt down prey, but the ability to survive and get away from a predator and distract it in this way is truly a power that you just can't ignore.
It's the same sense of awe that drives David Gardner's work with salamanders, whose secrets could yield far-reaching benefits for mankind.
I think people can really appreciate why regeneration becomes important. We go through life, we have accidents. Most of the accidents we can repair, but some injuries are really traumatic. They result in loss of structure and function. And so the goal is, how do you go about replacing that? Ultimately, what we're talking about is that you could regrow a missing body part. Or the other possibility, the way to think about it, is if you have some kind of damaged or defective body part, then you could remove that and then grow a new one.
In David's future, not only will we be able to regrow limbs, but patients with cancer could simply have tumors removed and replace damaged organs with new regenerated ones.
There's always been people writing about the fountain of youth, the idea of immortality. That's the heart of regeneration, is that the cells can just keep repairing and repairing. We share the essential genetics. It's not whether you've got it, it's how you use it.
The salamander, electric eel, and octopus all have amazing powers, engineered by nature to survive against all odds. Millions of years in the making, their secrets of survival are now slowly being uncovered. They offer the tantalizing opportunity that one day we too may possess these animal superpowers.